let us see another application, that is the fourth application, application 4, that is halogenation of alkanes. Halogenation of alkanes. So, in this reaction, how this inductive effect is we are applying, and how that is major product formation, minor product formation we are going to decide. Let us see. Fundamentally, the reaction happens to be a methane when treated with a chlorine gas in presence of the UV light or heating at 250 degrees, you will get the methyl chloride plus H. This is a basic skeleton reaction of the alkanes halogenation, in which one hydrogen is replaced by the chlorine, therefore, it is substitution. And the chlorine happens to be first directly it won't go and hit, it breaks up into dot and dot. So, one of the chlorine dot will attack on the methane and gives the methyl free radical plus HCl. Now, this methyl free radical is going to give the methyl chloride. So, this methyl free radical is called as what? A intermediate species. So, this is what you have to know, the major reaction. This methane either with the Cl dot or with a fresh chlorine, you can take it grant, either one will react and give. So, when methane to methyl chloride, what is the intermediate means? You must be very thorough that the methane losing the hydrogen in terms of free radical and forming into CH3 free radical, that CH3 free radical will give the ethane, right. So, like this, any alkane, if it is given the product, immediately we can notice what is the intermediate. Similarly, for example, ethyl that is ethane, for example, when it is brominated, okay, slightly changed the reagent and the compound and gave the ethyl chloride, ethyl bromide, isn't it? Now, can you tell me what is the intermediate means? Say, either from the ethane remove one hydrogen, get the intermediate, or remove the bromine, what you get is called intermediate. So, the intermediate of the compound is ethyl free radical, that gives the final product. Attacking species, leave it now, it is not coming into the picture of discussion. Now, you must be very thorough that in a given reaction, starting compound and final compound, if it is both are given, what is the intermediate species means? Either from the starting compound remove any one of the hydrogen, get the intermediate, or remove the bromine, you will get the corresponding intermediate, isn't it? So, without bromine, that intermediate on which we are attacking gave a final product. So, therefore, either from that side or from this side you can identify the intermediate. But if I give an example, like for example, I have a propane, how many hydrogens will be there? 8 hydrogens are there now. So, all these hydrogens are not identical. In the previous case, any one hydrogen you can remove. Here 6 hydrogen, any one you can remove, get the same intermediate, but here you are going to get 2 different intermediates. If one hydrogen on the first carbon if you remove, get a intermediate called what? N-propyl free radical. If the last carbon hydrogen, if it is removed. If the hydrogen from the middle carbon, if it is removed, you will get another intermediate called isopropyl. This is N-propyl, this is isopropyl. Basically, it is 1 degree free radical, it is 2 degree free radical. Now, however, if this free radical is involved in the next, that is if I treat it with chlorine UV light, so you will get a chlorine at on the first carbon, right. Or if this is involved, you will get the final compound 2-chloro. Now, which is formed more means as a fact that is more number of hydrogens, this 3 and 3, 6, any one of the hydrogen if you replace, you will get this one. So, as one you can probability approach, if you take, it is 6 times versus 2 times you should get, but actually the second product is becoming the major product. Why it is so means, it is not just the probability. Probability means 3 and 3 is identical. So, any one of these 6 hydrogens if you replace, you will get. Therefore, I expect 6 ratio, 6:2 ratio, that is 2 middle hydrogens. But what I am getting is a major product is 2-chloro I am getting. This is reason is here, if the middle hydrogen is removed, you will get a 2 degree free radical, which is better stable, because the free radical is considered as a electron deficient, and the more the alkyl groups attached, more will be stabilized. Here it is a free radical having only one alkyl, it is 2 alkyl. So, as we have seen, free radicals are electron deficient, more the alkyl groups, more will be stable. The order is 3 degree, 2 degree, 1 degree. So, 2 degree is more stable. So, as a more stable intermediate is involved, so more will be that this intermediate will be more formed because it is more stable. So, more naturally leads to you the major product. Once the intermediate is formed, this time required in the second step, the time required is almost 0 minutes. So, the entire delay is only the intermediate formation only. Intermediate is stable, therefore it will be fast. Intermediate is less stable, therefore it is slow. Even if it is formed also, the product will be formed quickly, but this formed itself is a slow reaction because it is not stable. This is a fast reaction. So, these both are fast only, second steps are both are fast only, 0 minutes actually almost. But here there is a fast and slow because it is stable, the reaction is fast. So, huge amount of 2 degrees formed. So, therefore, the 2 degree product will be the major one. Never say this chloro, that is 2-chloropropane is more stable, therefore, it is formed major. In some cases, no doubt, in some reactions, product is more stable. Out of the A and B, 2 products are formed. One product is major product. Why means sometimes answer will be like this. So, the B is major because it is more stable. That will be the answer. But here it is not the case. It is totally different. Never say the 2-chloropropane is more stable. That's wrong. Both are. We don't have a phenomenon to discuss the stability of the 2-chloro. But in the intermediates, we have a phenomena backed. That is that inductive effect says this intermediate is more stable. Therefore, the step 1 will become the fast one. So, because it is a dot versus dot reaction, instantaneously reaction takes place. So, second step is not delayed, only the step 1 in which this product formation is a fast and fast, therefore, the major product will be always in the formation of the, so in the favor of the 2-chloropropane. Like this, a number of examples you can discuss like this. For example, if I take a butane, what will be the major product? So, there are 2 different types of the hydrogens are there. The 3 hydrogens on the last this side, 6 hydrogens are same, but the 2 here, that is this 4 will be the same. So, either of 1 if you replace, you will get the 2-chlorobutane. If either of 3 and 3 if you replace, you will get the 1-chlorobutane. So, out of these 2 means again never discuss the stability of these 2, but the intermediate stability. What is the intermediate for this one? Intermediate is a 2 degree one, isn't it? Intermediate for this one is 1 degree one. So, 1 degree and 2 degrees, the 2 degrees major, this is more stable. So, therefore, you say this is the major one, right. So, like that, if a given compound, if it is a compound giving not necessarily only 2, it can be 5 or 6 compounds also, of which is the major one. If it is asked, see that the intermediates, what are the different intermediates involved for the each different product, that intermediate stability you see and then tell the answer. We have a few more examples, let us see. Let us take one more compound here. So, there is a 5 carbons are there, it is actually a pentane. So, if all the carbons are straight, we say N-pentane, but this gem dimethyl is there, therefore, you call isopentane. Systematically, how do you call? It is also called as 2-methylbutane, 2-methylbutane. Now, we have these 3 hydrogens, these 3 hydrogens are same type. Any one of these hydrogen, if you replace, you will get the compound like this. This type of product is formed. If the hydrogens replaced from the last 3, this last, you will get another type of the answer. This is the answer if you replace any one of these hydrogen. If hydrogens replaced on the second from this side, you will get one more answer. If the hydrogen replaced from the center carbon, you will get one more product. So, finally, how many answers are getting? You are getting 4 answers are same compound, and however, we have a restriction. What is that? Monochlorination. Why monochlorination? Because otherwise if 2, 2, 3, 3 enters, the discussion will become much more complicated. So, let us restrict to this particular condition. What is that? I allow the only one chlorine to enter. Okay. Then this may go out of the 6 one product. This is identical to this carbon, these 2 are methyls are identical. So, each hydrogen is identical. 3 plus 3, 6 hydrogens, let us say A type, these 3 are B type, these 2 are C type, this is D type. Therefore, 3, 4 answers are coming, okay, of which we have this is called N-pentyl, N-pentyl, N-propyl, N-butyl, N-pentyl, and this is called tertiary pentyl. The other 3 you too can say this is called secondary pentyl. It is not correct in fact. So, others say you have to go for the systematic nomenclature, but common names are fair. N-pentyl chloride, tertiary pentyl chloride. Okay, these 2 you have to say that is 1-chloro 2-methyl butane and 2-chloro 3-methyl butane, like that you have to name it. So, all will have their IUPAC names however, but out of these 4 compounds, which is the major? So, never come once again not the stability of these answers, its intermediate stability. That means, if the terminal hydrogen is removed, 1 degree comes. This carbon, if hydrogen is removed, you will get a 3 degree. That means, this compound intermediate, let us see, intermediate means I said from the answer chlorine substituted here. So, therefore, at that carbon if you can put a free radical, that will be the intermediate for this system. So, therefore, let us write that intermediate here. So, this is the intermediate for this the last compound, which is having a 3 degree nature. That means, deficiency is given by 3 sites, 3 alkyl groups are donating small electron density. So, more satisfaction are, that is the fulfillment of the instability. So, it will give the most stable intermediate 3 degree one. So, here only 2 degree, here it is 1 degree, here it is 1 degree. So, this is the only the one which gives a 3 degree and most stable one. So, therefore, this compound will become the major product, right. So, like this the question is first of all monochlorination, how many answers? This is a sort of isomerism or nomenclature type of the question in fact. But out of these answers, which is the major and what is the reason for the major? Reason is here, its intermediate is more stable. Never say that compound is itself is the stable one, isn't it? Its intermediate is 3 degree and it is more stable. So, more stable one generally will have a less reactivity, but the second step happens to be the dot versus dot. It is a very fast reaction. So, only the delay is formation. When once it is stable, the delay will become fast. So, therefore, the reaction will becoming the fast. So, similarly, there is one more example. In fact, the entire alkanes, the best the concept oriented question, if somebody wants to frame, it will be from the halogenation reaction, right, in the properties of the alkyl, that is alkanes. So, this compound, if it is chlorinated or monochlorinated, okay, monochlorinated in presence of UV light or around 250 degrees, you have at this terminal 3 hydrogens, junction 1 hydrogen, this and this is identical, these 2 are identical, this is identical. Totally 1, 2, 3, 4, 5 answers are going to come. Out of that, what is the major product? So, my question is very precise now. I am not asking how many answers. In fact, this and this identical. So, therefore, same, these 2 are identical. This is different, this is different, this is different, this is different, this is different. So, 5 answers are coming and the major answer happens to be the in the junction, that is the chlorine coming at the junction. So, why it is so? If somebody asks, the dot formed at the junction will be the 3 degree free radical. That is why it is more stable. So, therefore, the more stable product is formed, right. So, the reaction is not in view of the final compound stability, it can be judged in the, which also can be in the other way can be said. If I have different types of the hydrogens, the 3 degree hydrogens are more reactive than 2 degree hydrogens, than 1 degree hydrogen. You can, in the other way you can display the information like this, but it is nothing but the same. Why 3 degree hydrogen is more reactive? Because if that hydrogen is cut and gives a free radical which gives a 3 degree, therefore, it is going to give the intermediate fastly. So, So 3-degree hydrogens are more reactive. So the message can be given in the other way, but it is nothing but the same thing. So whether the all the hydrogens are same equally reactive in propane? No, middle hydrogens are more reactive. Why? Its intermediate is more stable. The other way question can be framed. But finally, this is the one beautiful concept involved in the alkanes halogenation. If one question comes from the good concept oriented or basic reason oriented, logical support containing question means in the halogenation, identification of the major answer will be the most beautiful, and it is supported by what? The stability of the intermediate backed by the phenomenon called inductive effect. More the inductive effect groups are attached, such a type of 3-degree free radical if it is involved, no doubt corresponding answer will be the final, that is more or major product will be there.